In example 2, we have a supermarket that sells two brands of granola. Brand A for a price of P dollars per pound, brand B at Q dollars per pound, and the daily demands for the two products are given by these two functions. One for the demand of the first product, one for the demand of the second. So what we want to find are dx dp delta x delta p and delta y delta p, so the partial derivatives of each of these functions with respect to p, and then we want to provide an interpretation for that. So what we want to find is the derivative of 300 minus 4p plus 7q with respect to p, since we want delta x over delta p. So the derivative of this equation x with respect to p. And what we get is a result of -4. So before we flip back, we'll go ahead and find the derivative of the other expression, y. So we also want, in part b, delta y over delta p. So we want the derivative of the other equation, still with respect to p. And here we get a result of 9. So we found delta x over delta p to be -4, delta y over delta p to be +9. So to interpret this first result, a $1 increase in the price of, in this case, since we're differentiating with respect to p, the thing that we're changing is the p dollars, which relates to brand A. So a $1 increase in the price of brand A, in this case, will result in a decrease, since we have a negative result, will result in a decrease in the demand for brand A by 4 pounds at any price level PQ. And we said any price level PQ because there's no variable left in this derivative. So regardless of what the original prices P and Q are, we're always going to see that decrease of 4. Our other result, 9, which is the derivative of our equation y equals this expression, with respect to P, tells us that a $1 increase still in the price of, in this case, differentiating with respect to P, means we're still changing the price of brand A. So if we increase the price of the brand A granola, we'll increase, since this is a positive result, the demand for Y, which Y represents the demand for brand B, by, in this case, 9 pounds at any price level PQ. So again, getting these derivative results and then applying that concept of rate of change to interpret what those results tell us. In example 3, we have a college newspaper that spends X thousand dollars a year on newspaper and television advertising and Y $1,000 on mailings and brochures. Total cost in thousands of dollars for these advertising revenues is 6x squared plus 5y. So the first thing we want to find is C sub x and C sub y. So the partial derivatives of 6x squared plus 5y with respect to both x and y. So again, we get both of those results output at the same time with a comma separating. So one result is 12x, the other is 5. So this tells us that cx, c sub x, the derivative with respect to x, is going to be 12x, and the derivative with respect to y will be 5. So if we evaluate the derivative with respect to x at 15, 35, we want to get that result and then look at how we can interpret that. So what we want to do is evaluate 12x for x equals 15 and y equals 35, but there is no y value in that function, so we don't really need that piece of information. We get a result of 180. So what this means is that if some amount is being spent on advertising, that's our x coordinate, and in this case those amounts are in thousands of dollars, so 15 really means 15,000. So if $15,000 is spent on advertising and $35,000 is being spent on mailings and brochures, then our cost is going to increase by the 180, but again in thousands that makes this 180,000. By $180,000 if advertising costs are increased by 1, which again in thousands means increase by 1,000. We also want to evaluate c sub y, so the derivative with respect to y, at 15, 35, and interpret the result. So evaluating the derivative with respect to y at any value is going to give us 5, since that's a constant function. So what this tells us that is that if $13,000, I'm sorry, that should be $15,000. If $15,000 is spent on advertising and $35,000 is spent on mailings and brochures, then the cost is going to increase by our result here of $5,000. If advertising costs increase by 1, which again in thousands means increases by $1,000. So in one case, if we increase spending on advertising, we see an increase of $180,000. And let's actually fix this second statement. There's an incorrect piece here. So in the first statement, we're differentiating with respect to x, meaning we're changing how much we're spending on advertising. In the second case, we're differentiating with respect to y, meaning we're going to change how much we're spending on mailings. So if we increase the amount that we're spending on mailings by $1,000, we see an increase in cost of $5,000. So we can easily see where the better choice is if what we're concerned with is keeping those costs down. Increasing our advertising costs is going to increase total costs by $180,000. Increasing the number of mailings is only going to increase our cost by $5,000.